Okay, students, good morning. Today, what we will continue with our per unit system analysis. We will solve this problem. I will prefer if you have downloaded this one from the link that I have provided in lecture 1, or you can download it now. You can keep it in your site either as a hard copy or soft copy, so that it will be helpful while solving the numerical. So you see in the problem there is a generator. Generator is there, one transformer T1. Some loads are connected. Transformer T2 is also there. This you can consider T2. So this is nothing, but you forget this. So this is your T2 transformer, and this is your T1 transformer, and in between them this is the transmission line that they are talking about. So what is our while solving this type of question for per unit, the first job that you need to do is to segregate this. How to segregate this? So let me show. Whenever there is a transformer, you segregate from that part. That means you segregate this part in between that winding. This is one part. Between that winding, that is another part up to this one. And then from the rest, there is another one. So there are three parts. One is between T1, and this is up to in between T2. That means you go inside the windings. That is when here I can't show here, but in T2 you can see. So you take one winding. This is one side. So this one we will say generator side. This is we will say transformer. This we will say motor. So you do this segregation part. So first of all, then what we will do, then you see we have to define the base. So what is the, in the questions if you read it, it is given the any base you can consider, but here it is given the base of the generator should be taken as base quantity. So generator base is here 100 MVA 33 kV. So that one they have considered to take. You can take any base depending on you, whatever base, or they can give from their own also. The 200 MVA you take base, 66 kV you take base, any base you can consider. So before solving it, you saw how many parts we have done. We have segregated this network into three parts. One is generator part, one is transmission line, one is motor part. So for each part you write the base quantities first. So you remember the MVA base remains same throughout the system, throughout the network. So MVA base remains 100, 100 and 100. So the base, what changes is the base voltage. So we will take care of that base voltage. So base voltage, first we will start from generator side. So as we have considered the generator base itself as the system base, so whatever written in the generator, it remains same. So generator base is 33. So my system base is also 33 kV. So the base for this portion is 33 kV. Now you think that you start with generator, then you think that you have thrown 33 kV from this side, and according to transformer ratio, it will automatically change from this side. Again there is a transformer, so it will change this side. So there will be continuous change of the base voltages. Whenever you cross a transformer, so base voltage is supposed to change. Suppose if the ratio is not 1:1, then it is supposed to change. So you can see in the transmission line what will be your kV base, because the ratio is 10/32. So accordingly this 33 kV from this side, here you have taken 33. So 33 jump out to this side with the ratio of this 110/33. So the base for the transmission line becomes 113.437. The calculation you can check. And then go for the motor load. So for the motor load again, you will jump from this side to this side. So what is there in this side? The base was 113 points. So this is my base. So again this will be transferred by this ratio, the ratio of the T2 transformer, which is this one, the ratio of this transformer T2. So you do the base of this side is 33 kV. Now you have base for all the three sides. All the three sides base you have with you. So we can proceed with our questions now. So we will convert the reactance in the given, here the reactance are given 15%, 8%. For T2 also it is 8%, same as T1, and for motor it is 20%, 20% and 20%. So percent is nothing but it is per unit. What we say in percent is 15% means in per unit it is 0.15, 8% means 0.08. So we'll take each component, generator, then transformer, then transmission line, then motor. We will calculate what will be the per unit value of that reactance in the new system base, because this 8% is given on this transformer base, this 20% is given on this base, but this is not the base. What is my base? 100 MVA, and this side base is 33 kV. So you have to change this. So we will go for one item starting. So if we start with transformer 1 T1, so now for transformer you have flexibility. You can think transformer is on this side also, is this side also, you can think on this side also, T1 transformer. But if you consider T1 side, this side, then you have to take this side system base. If you are considering this side, then you have to take this side system base. So you can see already the previous, the old per unit value is given 0.8. So we have seen a formula, long formula yesterday, old, new, old, new. So we are using that formula. So go to the new value. So new is this one. What is old value? Old value is given 0.08%. That should be 0.08. You make it a correction. It should be 0.08. It is 8%. So correct it. So it will be 0.08 because it is 8%. Then what is MVA base new? These are the new bases, MVA and KV. These are the old bases. What are the old bases? If I am considering transformer that side, then it is 110 is the MVA base, and the KV base is 32 because this side is 32. This is 32 by 110. So that's why they have considered this side is 32. So the old is considered this side. So the new should also be on this side. So what is generator side? This is 33. If you want to consider in that side here, suppose if you want to consider, then what should be your KV old? Your KV old should be 110. You could have written it 110 divided by your new base, that is this side new is 113.43, and then put a whole square on that. So you could have done this one also, but this will also work. Whatever, in transformer you have flexibility. You have choosing old for this side, so new also you can choose this side. If you are choosing this side, then old, new both should be of that side. So you have both winding, primary, secondary. In whatever winding you want to go, you want to change. You can go. So the new value is this one of transformer 1. So transformer 1, T1 and T2 both are identical. So you can use T2. So if you want to, suppose you want to do it for T2, you want to write the equation for T2. So for T2, what you can do, if you want to write the T2, so T2, what will be the XPU old? That is same 0.8, so it will be 0.8. And then what is the base? New base is you want to go for 100 MVA is the new base. What is old base? 110 multiplied by KV. What is KB old? If you are considering this side as a base, so old base was how much? 110. This side transformer was 110. So what is new base this side? The new base is this one in transmission line. This is 113.43. You put a whole square. So you can find the same thing that we have written in last for this one also. So that's why T1, T2 remains same. Now for transmission line, if you go for transmission line, there is a impedance given for transmission line, absolute value. What is the impedance given in transmission line? This is given 50 ohm. The transmission line impedance is given as 50 ohm. So going for transmission line, so transmission line ZPU is equal to Z actual by Z base. What is Z actual? This is given in the question. Z actual is 50. Z actual is 50. And what is Z base? Z base you have written, you have seen in the formula, it is MVA KV square by MVA. So if you are write the KV, it is in transmission line. So what is the transmission line base? We have calculated 113. So this square, what is MVA? MVA for the entire system is 100. So you can find the transmission line ZPU is equal to 0.3886. So if you go for now motor, for the motors also you can see these are already given. Old per unit values are given. So but these are in these values, corresponding base values. So you have to change it. You have to go for a common base value for the entire system. And we have considered the base value for the motor part. This one is the base value for the motor. So we will be using this one. So if you come to the motor side now, for the motor 1, again the formula is the old multiplied by new. New base is, new MVA base is 100 by old MVA base is 30 MVA for the motor, and it is KV. KV old is 30 and KV new. For motor side it is 33 whole square. So you can put it in for this one, this is I think 20. This is 100 by 20, that is old MVA. This is old MVA 50. So make these necessary corrections in your copy. So the per unit per U value you can find. This is the per unit values. So once we have done with all the parameters, all the equipments that are connected in our network, once we got the new per unit value, now we can connect. So the generator will be, the voltage source will be considered as a 1 per unit voltage. That is ideal case we are considering. It is delivering 1 per unit voltage. This is generator side reactance. This is transformer 1 reactance. This is transmission line. All are connected in a single line. This is transmission line 2, and this is the motor side. So motor side, there is a mistake is there in motor side, because you know motor is always represented with a voltage source. 1 pu, you will write 1 pu voltage source, and then this one. So you have to connect. So this one will be something a reactance, then a mode generator source of this. This one will be your 1 per unit, because we are considering ideal case. So in here also there will be one generator source, one generating source, because motor is always a voltage source and a inductor that is connected. That is the way the motor is represented. So you do the necessary corrections here also. So then this is the per unit diagram we are talking about. So up to this much we have studied. This one we will see how to calculate short circuit current and all other things in the next class. Okay, till then, bye. If you have any doubts, you can put it in the comment box. Do subscribe and press the bell icon for further notifications. Till then, bye. Stay safe.